friends, a very good morning to one and all. Today we will discuss some important questions on subsequence. First question is, let sequence of an and sequence of bn and sequence of cn be sequences of real numbers such that bn is equal to a to n and cn is equal to a to n plus 1. Then sequence of an is convergent implies that we are given with three options. Option A says that it implies that sequence of bn is convergent but sequence of cn need not be convergent. Option B says that it implies that sequence of cn is convergent but sequence of bn need not be convergent. Option C says that it implies that both sequence of bn and sequence of cn are convergent. Here clearly option C is correct, which says that it implies that both sequence of bn and sequence of cn are convergent. Now let's discuss another question, which says that if sequence of action is a convergent sequence in R and sequence of yn is a bounded sequence in R, then we can conclude that we are given with four options. Option A says that sequence of action plus yn is convergent. Option B says that sequence of action plus yn is bounded. Option C says that sequence of action plus yn has no convergent subsequence. Option D says that sequence of action plus yn has no bounded subsequence. Here clearly option B is correct, which says that sequence of action plus yn is bounded. Now we will discuss this with the help of an example. We take sequence of action is equal to sequence of 1 by n, which is convergent, and we take sequence of yn is equal to sequence of minus 1 power n, which is bounded. It is bounded sequence. Now we will add. We get sequence of action plus sequence of plus yn is equal to sequence of 1 by n plus minus 1 power n, and it is oscillatory sequence, and we know that an oscillatory sequence is bounded. If n is even, then it has convergent subsequence. Now we discuss another question. Question is, which of the following statements about sequence of real numbers are true? Option A says that every bounded sequence can have convergent subsequence. Option B says that every sequence has a monotonic subsequence. Option C says that every sequence has a limit point. Option D says that every sequence has countable number of terms. Here clearly option A is true. Option B is also true. Option C is not true, and option D is also true. So correct option is D, which says that option A, B, D and are true. Now we will discuss why option C is not true with the help of an example. We take example of sequence of natural numbers. Here clearly in sequence of natural numbers, limit point does not exist, which contradicts the statement which says that every sequence has a limit point. Now we discuss another question. Let sequence of n be a bounded sequence of real numbers. Then we are given with four options. We have to tell which statement is correct. Option A says that there is a subsequence of sequence of n which is convergent. Every subsequence of sequence of n is convergent. Option C says that there is exactly one subsequence of sequence of n which is convergent. Option D is none of these. Clearly option A is correct, which says that there is a subsequence of sequence of n which is convergent. Now we discuss another question which says that if a sequence an is bounded, then the sequence we are given with 4 options. Option A says that has no convergent subsequence. Option B says that has a convergent subsequence. Option C says that the sequence must be converged. Option D says that the sequence is monotonic. Here clearly, if a sequence n is bounded, then the sequence has a convergent subsequence. Therefore, option B is correct. Thank you and have a nice day.